All right, so this is the Unit 2 study guide video. I'm gonna do my best to kind of make this quick. Feel free to fast forward at any time if you need to see a particular section. Okay, so let's start with section 1. It says write all the number of significant figures that are in each of these correctly taken measurements. Okay, so when it comes to significant figures, there's a few rules you need to make sure you are following. It mostly deals with the zeros. Okay, so if you look at number 1, anything that's not a 0, like a 2 and a 3, are going to count as significant figures, so that's at least 2. Now I'm going to look at these trailing zeros. I'm going to see, is there a decimal there? If there is not a decimal, these trailing zeros do not count. Okay, so this would only be 2 significant figures. Now number 2, I do have a 0, but if you look, it's sandwiched in between 2 non-zero numbers. Okay, so if it's sandwiched in between those, it's definitely going to count. Okay, so we're going to count. So I have 1, 2, 3, 4, 5. So there's going to be 5 significant figures. 3, same thing. Zeros are all sandwiched in between. So this is going to be 7. Okay, 4, same thing, sandwiched in between. So there's going to be 4. Now number 5, I do see a decimal here, but please make sure you do not count any leading zero. Even if there's a decimal there, leading zeros never count. Okay, decimals are only important for trailing zeros. So this one only has 1, 2, 3. Okay, 6, got a 0 sandwiched in between. Okay, so that's going to count, so this will be 5. Number 6, I've got both trailing and leading. So I'm going to look at these leading zeros. I'm going to cross those off because those never count. Now, since there is a decimal, this trailing 0 is going to count. So this is going to be 3. 17, I do have a decimal, so all these zeros are going to count. So this is going to be 4. 18, I'm going to cross off these leading zeros because those don't count. And I do have 2 trailing zeros, so this is going to be 4. Number 19, I see a decimal, so all those trailing zeros are going to count. So this is going to be 5. Then number 20, I was thinking because we have 2 sig figs here because I don't see a decimal anywhere, so that 0 is not going to count. So this is going to be 2. 21, those 0, no decimal, so these are not going to count, so this is going to be 2. All right, so now number 2 is rounding. Okay, so we're going to do 5 sig figs first. So I'm going to do is I'm going to count 1, 2, 3, 4, 5. I'm going to draw my line in between that 5 and 9. I'm going to use that 9 to tell me if I round up my 5. So anything that's 5 and higher, it's going to make me round my next number up. So my 5 sig figs would be 6.1316. Okay, so I'm going to erase this real quick so I can clear this up. Okay, now I'm going to do 4 sig figs. So I would count 1, 2, 3, 4, draw my line. That 5 tells me I'm going to round that 1 up. So this is going to be 6.132. Okay, let me erase this. Now it's going to go 3 sig figs. So I'm going to count 1, 2, 3, draw my line. This 1 is going to tell me I am not going to round up. So I'm going to leave that 3 the same. I'm going to leave it alone. So it's just going to be 6.13. Okay, let's jump down to the next one because I want you to see this one because it deals with a 0 involved. Okay, so if we look at 7.59530 and I want 5 sig figs, I'm going to count 1, 2, 3, 4, 5, draw my line. Okay, that is not going to round up, so it's just going to be 7.5953. Okay, so let's clear this up. Let's do 4 sig figs. I'm going to count 1, 2, 3, 4, draw my line. Nothing's going to happen, so it's just going to be 7.595. Okay, now it gets to the point where we have to round and we have to keep a 0. So I need 3 sig figs, so I'm going to count 1, 2, 3, draw my line. That 5 is going to make my 9 round up, but it's going to actually turn 59 into a 60 because it's going to continue over to that 5. So I do need to keep that 0 because I need 3 sig figs. So I'm going to put 7.60. Okay. And then 2 sig figs. We'll just finish this one up just so you can see the 2 sig figs. Okay. I'm going to count 1, 2, draw my line. That 9 is going to tell me to round that 5 up. So it would just be 7.6. Okay. So that was the rounding section. 3 is express the following in scientific notation with the correct number of significant figures. Okay, so one thing you really need to get in the habit of is counting your sig figs before you even start. Okay, because whatever you have in the beginning needs to be what you have in the end. Okay, so if this 5 and 8 are significant and these zeros are not in the beginning, I only need 2 sig figs in the end. Okay, so what we're going to do is when we're going to scientific notation, you have to start where the decimal is or where it would be. So on letter A, my decimal would be right after that last 0. Now what I'm going to do is I'm going to go to the left. So it's a big number. So we're going to go to the left until we get to a number between 1 and 10. So I'm going to go left 1, 2, 3 times. So that gives me the number 5.8. So it has to be a number between 1 and 10. Otherwise, it's not going to work. Now, I'm going to put times 10. Okay, and I'm going to count how many times as I go to the left. I went over 3 times. And since this is a big number, it's going to be a positive exponent. The way I remember that is if it's a big number like that, if that was like my bank account, I'd probably be a little bit more of a positive person. Okay, versus like a small number, I'd probably be more of a negative person because I don't have much money in my account. So that's one of the ways I remember it. So letter B, I'm going to do the same. So I'm going to go over, I'm going to start where the decimal would be. It'd be that last 0. I'm going to go left 1, 2, 3, 4, 5 times. So that gives me a number 4.5. I'm going to check. Okay, I have 2 sig figs in the beginning. Remember, those zeros don't count because there is no decimal. So all I need is 4.5. And I'm going to do times 10. And I went to the left 5 times. Okay, so that's my new answer. Also, I forgot to put my units on there. So if you do see units, make sure you please keep those on there. Okay, I'll do C and then I'll jump over to the small numbers. So I'm going to start where the decimal would be. So 1, 2, 3, 4, 5, 6, 7, 8. Now I'm going to look at my sig figs. I have 1, 2, 3 sig figs. So I'm going to keep those in my answer. So I get 3.02 times 10. And I went over to the left 8 times. So there's my answer. Now on small numbers, you're going to start where the decimal would be, and I'm going to go to the right. So I'm going to go to the right 1, 2, 3, 4, and I'm just going to stop just past that first number, okay, because that gives me the number 5.08. Let's check my sig figs. I have 1, 2, 3 in the beginning. I've got 1, 2, 3 in the end, so I'm good there. Now I'm going to do times 10, and now I went to the right 4 times, but this is a small number, so this is going to be a negative 4. And then I'm just going to keep my units there at the end, so kilograms will be my final answer. Left, so let's do F. So we're going to start with the decimal would be. I'm going to go over 1, 2, 3, 4, 5, 6, 7 times. Let's look at my sig figs. I have 1, 2, 3, because remember that 0 counts because there's a decimal. So I do have to keep it 4.50. So please make sure you don't leave off that 0. Okay, and we're going to do times 10. Now I went over to the right 7 times, so it's going to be negative 7. And it's going to be kilograms, and then that one's done. So I'll do one more. So I have 0.0003600. I'm going to look at my sig figs. I have 1, 2, 3, 4 significant figures here, so my answer does have to have 4. So I'm going to start the decimal 1, 2, 3, 4 times. So this is going to be 3.600 times 10 to the negative 4 kilograms. All right, so let's move on to the next section. Now we're going to go backwards. Okay, so we're going to go from scientific. So the key thing to do here is make sure you look at the exponent. If it is a positive, that means it's a big number. So you got to think, which way would the decimal go to make it a big number, right or left? So in this case, I'm going to move to the right because I want a big number. So 1, 2, 3, 4, 5 times. Just please make sure this is why we say correct number of significant figures. I'm going to count and see what I have. I have 1, 2, 3, 4, 5, 6 significant figures. All these are significant because there's that decimal there. So I do have to keep that in my answer. So what I do is I get 580,100. And what I'm going to do is I'm going to keep that decimal at the end because that makes all those zeros significant. So my answer would be 580,100 with a decimal seconds. There's my answer. Okay, B, I've got 8.12 times 10 to the 7th. That's a positive, so I'm going to write this over here so I've got a little bit of room. So my decimals go right 7 times. So 1, 2, 3, 4, 5, 6, 7, and I'm going to fill in these zeros right here. Now I'm going to see, do I need to keep the decimal? I do not because I only need 3 sig figs. Okay, so now I've got 3 right here. If I did keep that decimal, you just told me all those zeros are significant, and now you don't have a matching number when you started. Okay, so my correct answer would be 81,200,000 meters. Now let's look at C. I have a negative number now, so this is gonna be a small number. So that means I go to the left 2 times. So 1, 2, my decimal is gonna be here. I'm gonna fill in that 0. So my answer is gonna be 0.050 kilograms. Okay, let's check my sig figs. I had 1, 2 in the beginning. I've got 1, 2 now. So that means I'm good. And there's my answer. D, I've got 2.110. Okay, so I'm gonna put over here so I got a little bit of room. It's a negative number, so I'm gonna go left 3 times. 1, 2, 3. So that means I gotta fill in these 2 zeros. So my new answer is gonna be 0.002110. Because remember, I have 1, 2, 3, 4 significant figures here. So I've got 1, 2, 3, 4 significant figures here. So I'm good. So there's my answer. Okay, so math, I'm not gonna do all of these. Okay, but I will get the gist because there's rules for adding and subtracting and there's rules for multiplying and dividing. Now it comes to adding and subtracting, the way I do this or the way I've been teaching my class is to line it up like elementary school. Okay, so that means we're gonna stack it. So I've got 258.3, then I've got 257.11. Okay, please make sure your decimals have to line up, otherwise this trick will not work. And then I've got lastly 253. Because that decimal would be right here. Okay, so what I would do is I'd add these up, but I've got to look is when it comes to adding and subtracting, you have to go by the least accurate number. And what I mean by least accurate is basically it has the least amount of decimal places. The further you go to the right, like into the decimals, the more accurate you are. So if I was to choose which one of these is the least accurate, I would choose 253 because they don't even have any decimals. Okay. So that means that's where I have to stop, is I have to stop just past that 253. I cannot go any further than that ones place. I'm still gonna add it up. I still get 1, 4, 18, carry the 1, that gives me 16, carry the 1, gives me 768. Okay, now what I'm gonna do is I'm gonna use this 4 to tell me, do I round up or not? I'm not, so my answer is just gonna be 768 kilograms, and that's it. Okay, so once you draw that line, you cannot go past that. You can use the number to help you round, but you cannot go past that. Okay, so let me clear this up a little bit so I have a little bit of room. Okay, so again, feel free to rewind, pause, and then try, or fast forward if you need to. Okay, so I'm gonna look at B. Now I've got multiplying and dividing. Now multiplying and dividing is usually a little easier, is you just count the least amount of sig figs. Okay, so if I looked at 13.65, that would be 4 sig figs. 23.20 would be 4 sig figs. 42.0 is 3 sig figs. So you're only as good as your weakest link. So that means my answer can only have 3. Okay, so whenever I do my calculation in the calculator, I get the number 13,300.56. Okay, so what I need is I need 3 sig figs. I'm gonna count my 3, 1, 2, 3, draw my line. That 0 is not gonna make me round my 3 up. Now, but please do not make this mistake. Again, I like to refer to like my bank account is what happened if the bank rounded my $13,300 to $133 as my answer. Okay, I would not be a happy person. Okay, so what I'm gonna do is I'm gonna keep those zeros just past the line, but I don't have a decimal, so that means those zeros don't count. Okay, so my answer would just be 13,300, and this would actually be centimeters cubed, but we're not too worried about the units on that. We just care mostly about the sig figs. So just please make sure, do not round a big number to a small number just because you stopped at that line, okay? You can put as many zeros as you want past that line, whatever you need, because they're not gonna count because I don't have a decimal. Okay, so let me jump around a little bit. Okay, let's come over here to F. Okay, I have 93.26 minus 81.140, so I am going to subtract this. I'm gonna stack it. So I'm gonna do 93.26 minus 81.140. Please make sure your decimals line up. Okay, so I'm still gonna do my math. This comes out to be 12.120, but I gotta figure out where to stop. Okay, so I'm gonna choose who's my least accurate number. Well, it would have to be 93.26 because it only goes to the hundredths place. The 81.140 goes all the way to the thousandths place. Okay, so I have to stop at whichever one was the least accurate. Okay, so my answer would just be 12.12 centimeters. Okay, now I'm looking at G, 4.84 divided by 2.4. I have 3 sig figs here, 2 sig figs here. My answer can only have 2. So when I type in the calculator, I get this long decimal number. I get 2.016667, and I only need 2, so I'm gonna count 1, 2, draw my line. This 1 tells me I am not gonna round up. So my answer just comes out to be 2.0. Now for units, I understand this has got a little confusing because we didn't do a whole lot of this because we're going to do this stuff later on, is if you have two different units like grams and milliliters, don't worry about trying to convert one to the other because you can't. They're two different types of measurements. Okay, your units would just be grams divided by milliliters. Okay, so like on H, whenever you did your math, it would just be meters divided by seconds. Okay, now on our test, we're not going to really throw much of the multi-step functions on you, but I will show you just in case you're a little bit confused on that. So like on letter J, we always do is you're going to do your parentheses first. Okay, so what I'm going to do is I'm just going to focus on the parentheses. So I'm going to do 8.807. I'm going to add 7.91. Now we're still going to follow by the rules. Okay, so we're going to see who's my least accurate number. Well, that's going to be the 7.91 because it stops at the hundredths place. Now when I add this up, I get 16.717. I am going to use this 7 to round that up. So my parentheses answer would be 16.72. Now what I'm going to do is now I can move on to my multiplying. So I'm going to use that rule now. So I have 4 sig figs here, 2 sig figs here, so my answer can only have 2. So when I get my calculator, I am going to get 88.616. But I only need 2 sig figs, so I'm going to count 1, 2, draw my line. So my answer comes out to be 89, and that's it. Okay, so that's the math. Just make sure you do not confuse the adding and subtracting rule with the multiplying and dividing rule. So please feel free to, if you need to rewind that and see that again, go for it. Okay, these are just SI units for the following table. Remember, SI units are basically units that are used across the world. It's basically like it's called basically Standard International. So that way, whenever we're doing research, everybody's using the same thing and we're not having to convert back and forth between whoever wants to use this unit, which can lead to errors. Okay, so for length, it's going to be meters. Okay, so like whenever you go out on the track, you can run in meters. Okay, symbol would be the letter M. Now mass is going to be kilograms. And its symbol is going to be kg. Time is pretty easy, it's just seconds. And its symbol is just the letter S. Okay, volume can be liter or meters cubed. Either one will work. So if you want to do L for liter, or you can do M cubed. Now the reason why is because the equation for volume is length times width times height. So M times M times M gives you M cubed. Now temperature, we'll do this a little bit later on. We're not going to worry too much about Kelvin right now. And its symbol is letter K. And the amount of substance, we will do that later on. That's actually called a mole. Okay, so the amount of substance is called a mole and its abbreviation is MOL. So just take away the E and there you go. So questions like this could be like, which of the following is the SI unit for blank? Or which one of these is not a correct SI unit? So that's what we can expect from a table like this. All right, as far as your metric scale goes, I don't really want to worry about filling this out. This is just adding 0. I can do a little bit. So like your base, there is no abbreviation for base. That is just 10 to the 0 power. That is just your center. And that's just going to be the number 1. So like deca, that's going to be your next step. So that's going to be dA. Okay, and then your power would just be 10 to the 1. So we're just going to add a 0. So now you went from 1 to 0. The next one, okay, so that is going to be hecto. And that's by the abbreviation H. Okay, and that's 10 to the 2, so that means you're just going to add 2 zeros. So you kind of get the point is each time you go up, you see the power, and that's how many zeros you're going to add. Okay, so these are powers of 10. Now let's go the opposite way. Okay, so on the other side of base unit, I have deci. That is going to be just the lowercase d. Okay, that's going to be a 10 to the minus 1. Okay, and it's going to be 0.1. Okay, so it's always going to be 1 less. So like on the top section, we just added a 0. On the bottom section, it's always going to be 1 less than the number. So if I looked at centi, which is letter C, that's going to be 10 to the negative 2. So I'm going to take that decimal and I'm just going to add 1 0, so that's 0.01. Okay, so do you see how my number is 2, but I only have 1 0 in between the decimal and the number? So it's always going to be 1 less. If I looked at the next one, that would be milli, which would be the lowercase m. So 10 to the negative 3, that means it's going to be 2 zeros and then a 1. Okay, and I'm going to scroll down here in just a second. We're going to look at the metric scale just to kind of recap on that a little bit. I've got down at the bottom of this. All right, so your metric scale, again, you do not have to memorize this, just please make sure you know how to use it, and we're gonna do those here in just a second. Okay, so you start off at base units. So that means if you don't see a prefix at all, so like if you look at these letters down here, okay, they do not have a prefix with them. That means there is no lowercase k, there is no lowercase n before it. Okay, if you do not see a prefix, that means you're dealing with base units. That means it's 10 to the 0. Now, when you go left, it's deca, da, lowercase da. Okay, hecto, h, that's 10 to the 2. Kilo, lowercase k, is 10 to the 3. Then you have mega. Please make sure you know that's a capital M. That's 10 to the 6. Giga, capital G, 10 to the 9th. And then tera is 10 to the 12th, capital T. Okay, then 10 to the negative 1, that is deci. So please make sure you do not get deca and deci mixed up. So deca is da, deci is lowercase d. Centi, lowercase c, milli, lowercase m. Now please watch out for micro. It's that little fancy U or upside down H, whatever you want to call it. Okay, then it goes nano, lowercase n, pico, lowercase p, and femto, lowercase f. So we're going to use these here in just a minute. So let's go back up. All right, so let's do some metric conversions. So use the metric scale to convert the following. Show all work. Remember to use sig figs and box your final answer. Okay, so that means if I have 1, 2, 3, 4 sig figs in the beginning, I need to have 4 in the end. Okay, so what I'm gonna do is, I'm gonna show you 2 ways to do this. Whichever way works is totally up to you. Okay, so I'm gonna do the decimal way. Is if I look at centi, that is gonna be 10 to the negative 2. Meters, I don't see a prefix, so that's a base, so that's gonna be 10 to the 0. Now, if you wanna do the decimal way, you would look on the metric scale and you'd see which way you're going. So if you looked on the metric scale, centi's on the right, a base. So I'm gonna scroll down here real quick, just so you can see it. So that means I'm starting at centi right here, and I'm going towards the base, and that's gonna be 2 steps to get there. So the distance from negative 2 to 0 would be 2 steps. Okay, so that means I am going to go to the left. So remember, you're gonna follow whichever you're trying to get to. I was trying to get to base, so I have to go left 2 times. So that's how far my decimal is gonna go. So if I looked at 3,644. If I had a decimal, it would be right here. It's going to go to the left 2 times. So 1, 2. So my new answer is going to be 36.44 meters. Now, if you want to do the exponent way, what you're going to do is you're going to write out 3,644 times 10 to the negative 2, because that's centimeters. And you always minus where you're trying to get to. So minus is 0. So nothing really changed there. But if you are going to put it in scientific notation, remember this number right here has to be a number between 1 and 10. Okay, so I need to fix my decimal. So if I had a decimal, it'd be right here. Okay, I would move it to the left 1, 2, 3 times. Okay, now the way I remember this is if I have to move my decimal to the left, I have to add to the exponent. If I move my decimal to the right, I have to subtract. The way I remember that is on the metric scale, if you went left, you were positive, you're a big number. If you went right, you were a negative exponent because you're a small number. So I went over to the left 3 times. So what I'm gonna do is I'm actually going to take away the 0 because we don't need that anymore. And I'm just gonna add 3. So negative 2 plus 3 would give me 3.644 times 10 to the 1 meters, which would just be the same thing as this right here. Okay, so either way is fine. In this case, I would have probably done the decimal way. If anytime it's a short jump, the decimal way is usually easier. Okay, so you're more than welcome to do either way. So let's look at B. I have 74.5 kilometers to decimeters. So kilo is 10 to the 3. Deci, okay, that is going to be 10 to the negative 1. Okay, so we're trying to get from kilo to deci. So that means you're going from kilo to deci, which would be left to right. Okay, and that would be a distance of 4 jumps. Okay, so the distance from positive 3 to negative 1 will be 4. So if I do my decimal way, so 74.5, I'm gonna move the decimal to the right 4 times. 1, 2, 3, 4. I'm gonna fill in my zeros. I'm gonna count my sig figs. Before I have 1, 2, 3, so my answer only needs 3. So my answer would just be 745,000 decimeters, so dm. Okay, let's try the exponent way. So I would do is 74.5 times 10 to the 3. Okay, and I'm gonna minus where I'm trying to get to. So minus a negative 1, it is always minus. Okay, whenever you minus a negative, this turns these into a positive. So my new answer would be 74.5 times 10 to the fourth. But if you look, my answer is not a number between 1 and 10. So that means I need to move my decimal to the left just one time. So I'm just going to add 1 to that exponent. So it'd be 7.45 times 10 to the fifth decimeters. Okay, letter C. This one, I circled it on my key, okay, because I don't think we're really going to give you one of these. This is kind of more of a complicated one. Okay, so in order to do the decimal trick here, since you're already in scientific mode, okay, you need to be in standard mode to do that decimal trick. So I'm going to fix that. So it's going to be 7,3 with 5 zeros. Okay, so that's 7,300,000. Okay, so if I was going to do the decimal trick, I'm going from micro, okay, which is 10 to the negative 6, to hecto, which is 10 to the 2. So if I'm going from negative 6 to hecto, okay, I'm going to go to the left 8 times. So I'm going to take where that decimal would be to the left 8 times. 1, 2, 3, 4, 5, 6, 7, 8. So that actually means I have to add a 0. So my new answer would just be 0.073 hectograms. Okay, so if I have 2 sig figs here, 2 sig figs here, that means I'm good. So again, we're not going to try to really give you these because these can get a little more complicated. So I wouldn't worry too much about the ones that are in scientific. Okay, if I wanted to do the exponent way, you can do that. Okay, so 7.3 times 10 to the 6th. Okay, so now, again, you're in scientific mode, so you actually have to get rid of this 6. So 6 minus 6 will give you 0. Okay, so if I were to do 7.3 times 10 to the 0, and I'm trying to get to hecto, okay, I'm going to minus where I'm getting to, so minus 2. Okay, so this would give you 7.3 times 10 to the negative 2. So again, I wouldn't really worry about this one too much. This one's a little more complicated. I was just kind of showing it to you. So we'll do one more of these. So convert 2.75 megagrams to nanograms. So 2.75 mega is going to be 10 to the 6th. Nano is 10 to the negative 9. Okay, so this is actually going to be a long jump. So this is why the decimal trick might be a little more fun. If you have a long jump, I'll do it anyway. So I'm going to go to the right. I'm going from mega to nano. So that's going to be to the right 15 times. So I'd write out 2.75, and I'm going to go to the right 15 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this can get a little bit tedious. So my answer is actually going to be this giant number here, okay, with 13 zeros. So let's fill this out. Okay, so this is why this can be a tricky way to do it. If you're fine with doing this, that's totally understandable. Okay, is just please make sure you know what the answer would be in scientific mode, because usually on our answer choices, like if it's a multiple choice, okay, I'm not going to have that many zeros in my answer. Okay, more than likely it would just be in scientific just because it's easier. And also when you do this many zeros, it's also easy to leave off one or forget one. Okay, so that's why it can be prone to errors. So this answer would have just been fine. Okay, I have 3 sig figs in the beginning. I have 3 sig figs in the end because I did not keep that decimal in the end once I moved it. So please make sure you don't keep that decimal unless you need it. Okay, so I have 3 in the end, so this one's good. Now, if I'm gonna do the scientific way, doing the exponent way, it's a lot easier if the number is already in a number between 1 and 10 because you don't have to move it anymore. Okay, so this one's gonna be quick. So 2.75 times 10, mega is 10 to the 6th. I'm going to minus where I'm going. So minus, I'm trying to get to negative 9. So minus a negative 9. This turns into a positive. So my answer would just be 2.75 times 10 to the 15th nanograms. And I'm done. Since this is a number all between 1 and 10, that means I'm done. Okay. Now let's talk about precision and accuracy. So remember, precision is how close your measurements are to each other. Accuracy is how close your measurements are to the target, whether they are right on the target or they average out to the target. So please make sure you read through your problem. It says a group of students determine the density of an unknown liquid. The actual value is 1.34. Okay, so that means that's my target right there. Okay, we will give you a target, but you just need to make sure you are reading the problem to know what it is. So these are my three measurements. I have 1.34, 1.32, 1.36, described with a precise, accurate, both, or neither. Okay, so if I were to look at precision, I would see are my measurements close to each other? I'd say they're pretty dang close, 1.34, 1.32, 1.36, not too far off from each other. So I would definitely say they're precise because they are close to each other. Now, if I were to average those out, this would actually average out to roughly a 1.34, which would make it close to my target value or my actual value, which would also make this accurate. Okay, now let's go down to something like this. Is you have a bunch of thermometers, you're taking different measurements, okay, and we're gonna see how accurate and precise each one is. So please make sure you're reading through your problem because I tell you what the target is right here, which is 100 degrees Celsius. So if I looked at thermometer 1, okay, I have 98.3, 98.5, 98.4, 98.7. My average is 98.5, okay, which is not too close to my 100 degrees Celsius. Now, I know it can be considered close, but when you're talking about decimals, okay, that is actually a decent amount away when you look at some of the other thermometers. So I would say that thermometer 1 is not accurate because it's just not close enough to that target value. But if I look at my range, that's how far they are from each other. The measurements are from each other. Okay, they're pretty close. So this is actually not accurate, but precise. And for my y, it's just basically what I've been explaining is my average just was not close enough to my target. Okay, so that's why it's not accurate. And then my measurements are actually close to each other. My range is very small. Okay, so that means you were actually precise in your measurements. Now let's look at thermometer number 2. Okay, I have 97.5, 99.7, 96.2, 94.4. My average is 97.0, so it actually got worse. And they're jumping all around. My range is 5.3. Okay, so this is not accurate or precise. Okay, so it's neither. So that thermometer is not very good. Okay, let's look at thermometer number 3. Okay, 97.5, 102.3, 99.7, 100.9. My average is 100.1, so that's good. So that's actually pretty close to my target value. But my range is all over the place, kind of jumping all around. So that means this thermometer 3 is going to be accurate, but not precise, since those measurements are not close to each other. All right, last one, thermometer number 4. 99.9, 100.1, 100.0, 99.9. My average is smack dab on my target, so that's definitely accurate. And my range is incredibly small, so that means the measurements were really close to each other. So this one is accurate and precise. Okay. Now, when it comes to measuring in sig figs, okay, so I see a lot of confusion coming on measuring in sig figs, okay. So when it comes to measuring, you have to take a look at the measuring device first, okay? And we always have, the rule is you have to go 1 decimal place or 1 place further than you can actually see on the device. So in this instance, in this first one, I can see 0, 1, 2, 3, 4, 5. I can see the ones place, okay? So if I had a decimal, the ones place would be right here. I can see this. Okay, you need to take it 1 step further than you can see. That means you're going to take a guess on this next decimal place. This means this is where you got to go, is that first decimal place. So if I thought this was 3, okay, I'm not going to just say 3 centimeters because you'd be wrong. Okay, if you thought it was 3, it needs to be 3.0. Okay, so I would say 3.0 centimeters, and there's your answer. Now on letter B, almost same device, but if you look, now I have little bitty tick marks, so I need to take a look at what do I actually have on a measurement device. Okay, so I have a ones place because I have 0, 1, 2, 3, 4, 5, so I have a ones place right there. Now I also have these little tick marks, which count as 0.1, 0.2, 0.3, 0.4, 0.5, so that means I also have that 10th place. I also have that. So that means I need to take it 1 step further than you can see, which means you're going to have to go into that hundredths place. Okay, now this is where, as long as you're close, we'll accept it. It does not have to be a perfect number. So if I were to look at 4, so 4 right here, so 4.1, 4.2, it's somewhere in between that 4.2 to 4.3. Okay, so if you said something like 4.25, 4.26, 4.27, anywhere around that is totally fine. As long as you're in that range, you'd have been fine. But what we do care about is that you went to that hundredths place. So even though I can't see it, that's where you need to take it. Okay, C, a graduated cylinder. So first of all, you need to make sure if you see a graduated cylinder, you always measure from the bottom of the curve, not at the top. Okay, so if I looked at my measuring device, be careful on this. I see a lot of students, they see these tick marks and they think that's a tenths place. Well, if you look, I go from 40 to 50. So each tick mark is actually a ones place, 41, 42, 43. Okay, so if I can see 43, okay, so this is what I can see. Okay, I cannot see this tenths place. There is no decimal in here. So that means that's where I need to take it. So that's where you need to go. So if you thought this was 43 on the dot, okay, you would actually say 43.0. You could also say 42.9, 43.1. As long as you're close, that's totally fine. Okay, now these are just your SI units again, so I would not worry about electric current. Okay, I wouldn't worry about luminous intensity. Okay, so this is just the SI units we're dealing with, but we already kind of covered that. Okay, identify lab equipment. This is pretty self-explanatory. Okay, so you have your safety goggles or safety glasses right here. You have a beaker, which we'll use more later here. Okay, your test tube is going to be number 3. Your graduated cylinder is going to be number 4. And then your test tube holder, okay, which looks like you can actually pinch a test tube, is right here. Okay, but we're not worried about this too much. We'll do that more in the labs coming up. Now, safety hazards, we can give you questions on like which of the following symbols is this. Okay, so if I looked at this one, a flame should be pretty self-explanatory. It's flammable. Now, if you look like number 7, it looks like 2 test tubes are being poured on metal or hands. That means this is corrosion, meaning it will go through it. Okay, number 8, it looks like you see like a dead tree there. Okay, this means this is an environmental hazard. So that means do not pour it down the sink. Okay, we will tell you if you can. Okay, otherwise we have special containers that we actually have to dispose of properly. Okay, number 9, it looks like something blowing up. So this is going to be exploding bomb. Now we're not going to be dealing with bombs. Okay, but anytime you're dealing with heat and you keep a container near heat, okay, containers whatever's in the container wants to expand. So if that's like a glass bottle or a glass beaker or anything like that, and it wants to expand, that means it can blow up, which would not be a good thing. Now, 10, skull and crossbones, I hope that goes without saying. Okay, it can lead to death or acute toxicity. Number 11, it looks like so this is actually like if you've ever been like welder and stuff like that. Okay, your welding tanks, or like your acetylene, all that stuff tanks would look like that, a long cylindrical tank. So this is a gas cylinder. Now you're not going to deal with that much. Okay, our gas is actually fed in through the classroom, so you're not going to deal with that much. But it's important to know these safety rules and stuff like that. Please make sure you read these bottles, okay, on anything, whether it's in a classroom or at home. Okay, so don't mix chemicals that you don't know about because you can create something deadly real quick if you're not paying attention. Okay, so now let's look at safety rules. So number 12. Okay, now some of these may be fine. I'm just going to look for things that I'm seeing that could be wrong. Okay, one I'm going to look is adding water to acid. So remember we talked about in class is you never add water to acid. Okay, the acid, you have a lot of condensed acid. It can react very quickly with that water. Okay, so as soon as you introduce that water, it will start reacting, which can make it splatter, which would not be a good thing. Now you can add acid to water because acid's being introduced to a whole lot of water a little bit at a time. Okay, so please make sure you know that. And then also I do not see any safety goggles on here, so no safety protection. Okay, number 13, looks like she's staring right at a test tube that's being heated. Okay, it's pointed right at her face. Okay, so if you're heating something, things occasionally like to get away from that heat or it'll get so hot it will expand. Okay, so test tube should be pointed away. Okay, so basically anything, I wouldn't want anything pointed at me anyway, whether it's heat or not. Okay, but even if you are heating something, please make sure the test tube is pointed away. Okay, 14 is, one person's doing the experiment. I don't see any eye protection. And it looks like these 3 students are kind of just messing around. So that leads to, 1, you have distraction and horseplay. And I don't see eye protection, so no eye protection. Okay, so that's a big thing is when we're doing labs and stuff, you can be working with things like fire or dangerous chemicals. Okay, horseplay, I understand, can easily get out of hand, okay, which can lead to bad problems. So we take that very seriously. So please make sure you're watching out for that. Okay, then number 15 actually looks like he's doing good. So he just is not pointed at him. He's got eye protection on. If I could pick anything, I'd say maybe his sleeves should have been rolled up. Okay, but this one, that'd be kind of grasping for straws. So honestly, I would just say student is following rules. Okay, number 16. Okay, we should not be eating, so do not eat or drink. He's actually drinking from a beaker, so that's not a great thing. You never know what was in that thing. Okay, so do not eat or drink in a lab. Okay, you do not want to get chemicals on there that you can ingest. Okay, 17, looks like a girl that is sniffing a test tube. Okay, remember, you never want to sniff a test tube because that's basically inhaling the things that are going there. If you did, for some reason, need to smell, which we don't really worry about that, make sure you always waft, okay, not sniff. Okay, so we don't want to inhale those chemicals. Okay, so now it's coming down to here, true, false. So if it's false, we're going to correct it. So number 18, while in the lab, it is okay to begin touching or using items on the lab tables without being instructed to do so, as long as you know how to use and handle the equipment. That would be false. So please make sure before you start anything, okay, we have to go through directions first because, again, something as minuscule as adding water to acid versus acid to water, okay, can cause problems real quick. Number 19, if something is spilled or broken in the lab, just cover it up or kick it out of the way if no one knew you do it, okay, or no one saw you do it. Okay, this is going to be false. So I understand accidents happen. You just please need to let us know so we can dispose of things properly, especially if it's like glass. Okay, so we need to be careful with that. 20, if acid gets on your skin, the best thing to do is tell your teacher immediately and flush the area with lots of water. That is going to be true. Okay, so again, go to our sinks, just start flushing the wound. Okay, just keep doing it for as long as we tell you to. 21, when heating a test tube, the test tube's mouth faces away from you. That should be true. You never want it faced towards you. Okay, 22, the best place to throw away garbage or unwanted items is in the lab sink because teachers love to pick up other people's messes. They're going to be false. Okay, if you have trash, okay, just please keep the room clean. Okay, so just make sure it ends up in the trash. 23, the last one, it is safe to have loose long hair during the lab. That's going to be false. So unless you want a real quick haircut over an open flame, okay, you need to keep that hair tied back and out of the way. Okay, so hopefully this helped out. Please feel free to rewind, do whatever you need to, and please let us know if you need